Ja, velkommen tilbage fra pausen, og velkommen til vores YouTube-seere. Næste oplæg det er om webbaseret sikkerhed i web-applikationer, og det er Tore, som har tilbudt at holde det, og tak for det, Tore. Og jeg vil lige ind og læse lidt op på dig, fordi nok har du været underviser i vores lille butik i mange år, men det var lige meget sjovt at komme ind på din hjemmeside, og der kunne jeg jo se, at du startede med VIC 20 i 81. Og som jeg plejer at skulle lige præcisere for mine børn, vi snakker 1981, ikke 1881 eller 1781, som er lige så realistisk for dem, at deres far tossede rundt der sammen med gravballemanden. Siden er du så gået over stok og sten med mange sider af faget, men jeg synes, den røde tråd er den her blanding af dyb teknisk forståelse og så noget kombineret med formidling og undervisning, og det er jo så også det, du gør lige præcis for os og vores kunder, og stor tak for det. Senest har det været .NET, Cloud og i særdeleshed websikkerhed, og det du skal snakke om i dag, tror jeg lyder for mig som en afart af den OWASP top 1 sikkerhed, som hedder Broken Security, Access Security, som PT ligger øverst på listen der. Og jeg synes, det der kendetegner min erfaring med dine oplæg, det er, at jeg går altid noget mere bekymret derfra, end da jeg kom. Og det er jo sundt i disse tider at gøre det. Så tusind tak for at både dele ud og for at skabe lidt bekymring, så vi kan gå hjem og passe på vores webapplikationer. Så scenen er din, og spørgsmål, I har nok fanget det alle sammen. Det her det er mikrofonen, man får, hvis man skal stille et spørgsmål, og så må man gerne snakke lige ned i den. Så værsgo, Thor.
Okay, thank you. So, good morning. Nice to see all of you here today. So maybe I should also present myself. So my name is Nestenius. I'm from Sweden. One of my biggest achievements in the past, I created a web community called programmers7.com. Anyone who remembers from the past? Maybe? Usually maybe one or two. It was my full-time living for like 8 years, managing, operating, SEO, development, deployments, marketing, and creating content. So pretty fun. I'm also a Lund&Bendsen instructor. I've been that for many years, teaching architecture, web security, and .NET and Azure. I'm also recently received a .NET MVP award from Microsoft this year, so it also gives me a few more new interesting opportunities in the Microsoft space. Besides that, I really like to share knowledge. So if you go to my blog at nestenius.se, you can find a lot of posts about authentication, security, Azure, and .NET. I'm also the co-organizer of the .NET Skåne user group, so if you want to come to Sweden, and learn something about .NET, you can join that one. Or you go to Henrik's here's Copenhagen, .NET user group if you want to know, it in Danish, So that's one thing I do. I also try to be active on Stack Overflow, even though Stack Overflow is kind of going downhill, in popularity. I've been there quite a few times and answering over like 1,000 questions so far. And also like this today, to do public speaking at user groups and events and at companies. So I'm an instructor of Lund&Bendsen, and I do teach quite a lot of different topics. It's my kind of full-time job, covering everything from software architecture, CQRS, event sourcing, to authentication, and also a lot of OpenID-connect and authentication. Besides that, is also Azure Cloud and the kind of entire .NET stack from beginning to really kind of deep dive things. So that is what I do at my work. So today I'm going to talk about securing our cookies and what can go wrong here, and there's quite a lot of few things that can go wrong here. So we see in the news that cookies are stolen. People actually steal cookies nowadays. And if you really kind of look closer here, you can actually go to a black market and buy stolen session cookies for like, a few dollars. and that from that you can actually gain access to quite a lot of systems. So we're going to talk about cookies and what can we do to secure the situation, and and what are the dangers and problems in this space. And clearly, it's pretty devastating, that you lose your your source code to games, your kind of most important data, your source code. You lose that because you lose some cookies. There's more example of that. 700 gigabytes of electronic arts source code. That's quite a lot. We see examples of how we use stolen session cookies to bypass authentication. So clearly, it is a problem. So let's say a hacker steals my session cookie. And that means that if a hacker steals my cookie, he can continue browsing the website as me. That's how the web works. So clearly, the cookie is a very sensitive information. But the question is, we as backend developers, what can we do to try to detect if a cookie is kind of stolen? Can we do something? Any suggestions?
The cookie with the IP address. You could combine the cookie with the IP address, but
yes.
That would be not so nice if you go from Wi-Fi to mobile.
Yes. Yeah. So you could connect it to the tie it to the IP address, and that's a good thing to start. And of course, you change your IP address pretty frequently, so it's pretty hard to tie it exactly. But can we use the IP address for something? Can we, use it for something, but maybe not tying exactly the IP address itself? Any suggestions? Yeah.
Maybe you could look if it's suddenly in a different country.
Yes, correct. So you could actually look at the IP address to kind of detect, it's come from China, different IP address. Then you could actually automatically block it. So you could record the country of the IP address when you log in, and then if that country changes, that could be a signal that maybe we should ask him to re-authenticate. But how can we look up the country from the IP address? Can we do that? Yes, but how do we do that? DNS maybe not. It's not really that useful for geolocation. Any other suggestions?
IANA maybe.
What's that?
IANA, the name registry of all the IP addresses.
No,
the ranges.
yeah. I mean, so what you can do is you could actually buy a database. You could make a lookup database. So, for example, if you want to do like, let me see here. I have some links. So there's one called IP2 location. You can actually try to the demo, and they will kind of look up your details. I'm in Denmark, and then it tries to try to kind of look up other things, and that is of course random, pretty kind of not so accurate. But still, I think the country is kind of good enough. You could record that, and if that changes, you could actually ask the user to re-authenticate. But okay, we are developers. How do we do that in practice? So what they do is that they sell a database that you actually can and that database have different kind of amount of data inside it. So you could actually download this database like once a month. You update your system, and then you can do real-time lookups without an overhead. Of course, there are also APIs you could call, but that takes time, and you want to do it in-house. I actually used the IP2 location service for 20 years ago when I was running that community site, because I want to do real-time targeted advertisement based on the country. So if it is a traffic from the US, then I want to use the US advertisement networks. If it is traffic from Europe, I want to use a different one. So I could actually real-time show different content to the user depending on the country of origin. So that's pretty convenient. And there's many kind of, similar services for looking up the country from IP address. So I think that is a pretty kind of good starting point. But what else can we do to detect if the cookies are stolen? Any more suggestions? Box, Jakob.
Checking on the user agent.
User agent, yes. You could do that. So the browser sends quite a lot of information to the backend in every request. So you could record the user agent, also kind of accept, the language and other kind of details as a signal. And if those information changes during your session, you could ask the user to re-authenticate. I think that's fairly a good approach. And what else? Well, we have the browser fingerprint. So you can actually go to a website like this one, Cover Your Tracks, and here you can actually get a fingerprint of your browser's uniqueness. So basically it takes all the different clues, run some JavaScript to try to kind of identify just my browser on my computer, trying to get a checksum, some identity of my specific browser. So this website shows that in my case, my browser's fingerprint appears to be unique among the 280,000 tested browsers during the last 45 days. So the kind of advertisement companies, Facebook, Google, and all the kind of other companies, they can track you today using your browser's fingerprint. A browser, how unique can it be? But it's all about trying to combine all the little clues about your browser. So what can you do? What can you get? So basically, you can get, for example, all the browser plugins. And each one of you might have different browser plugins, and depending on the version and the order you install them, so that order and that list can be different. That's one thing. And that means in this case that you talk about entropy and bits of information, maybe not so unique, but still this is one of many clues. And then you can look at the time zone offset. You can look at the kind of time zone, the screen size. You can look at the fonts. And the fonts depends on operating system. It depends on the browser. It depends on, a lot of other things. Or cookie enabled. And a lot of other things. One interesting thing is to do a hash of canvas fingerprint. That sounds like that's odd. That's, what can that mean? Well, that one means that you actually, let's see if I can find the link. Yeah. So basically, what you do is you make an image, a hidden image in your browser, and then you take that bitmap image, and then you make a hash checksum of that image. And that image will look slightly different depending on the graphics card, the fonts, the shading, and the operating system. So the fonts will and the kind of shading will look slightly different depending on your physical computer and the graphics drivers. So that's one thing, and a lot of other things. And this is pretty kind of easy to do in JavaScript. You have a language, you can hardware devices, support, and do you have an ad blocker? It's all about trying to combine small clues, and together they can make a unique fingerprint from a browser. And there's even libraries for JavaScript that can do it for you. Here's one at fingerprint.com that gives me like a unique visitor ID that I can use in the backend to track one user across logins and similar. And of course, yes.
So is this using like IP address information, user agent, or is it only browser-specific things?
It's browser-specific because the IP can change. They won't be able to track you when you move from work to home, to the train, to Copenhagen airport. They want to track you across your entire browser kind of history. So this is, and you can also use it in your own system, because if you make, you do a lot of things about billing or like a bank, you want to ensure that, nobody steals a cookie. So you could remember that. It can also be a way to detect abuse, like one user logs in with 10 different accounts. If it's the same browser, but you have 10 different accounts, that can also be like a red flag in the system. So it can have a lot of kind of abuse and fraud purposes to be able to make a fingerprint on your browser. Any questions so far? Yes, one question.
And what do you do when you have system-to-system communication where you don't have a browser as such, but you instantiate the communication through the WebSocket in your application, and you don't have all these fingerprint items that you can actually rely on?
I think that's a different kind of a problem domain. I mean, you could use like, in that case, if it's server to server, you have OpenID-connect, you can send some tokens, or you can use, for example, you have something called, if you really want to kind of go high-end, you can use MTLS. So you have like a client-side certificate and a browser-side certificate, because when you use HTTPS, you have a server-side certificate. But you can also, if you want to, try to use as my kind of test site to see if it works. You can also use a client-side certificate in the browser to tie the browser so that the server can check during the connection handshake is the client who I expect. So this kind of a demo, the browser will pop up a dialog asking me, present which certificate do I want to authenticate against this website with. And in this case, I only have one. I'm making this one perhaps. And I press yes. I don't have access in this case. I can try, can do it another one again. Take this one perhaps. Will that work? No, none of those works today. But you see the point that you can actually, deploy a certificate in your browser or in the client application. If you do machine to machine, the sender of a request can have a certificate on its side, and then you can really ensure that have a secure communication. Does it answer your question?
To some extent, I think one of the bigger problems is that I know, or I think I know, the security boundaries on my machine, but the other end I'm communicating with, I'm not in control of.
Sure.
And have someone gain access to the memory or whatever, they can actually extract these information and then be man in the middle.
Yeah. And of course, that is always the challenge. If your client or server is hacked, it's game over anyway. So if they are in your server, then you have other problems.
But this is, if you look at the implementation of MID or whatever identification we have today, it stands on the things, the good old things. Something you know, something you have, and this is how do we implement a paradigm like that in secure communication? That's an interesting part.
Yes, it's interesting. It's all about crypto and keys everywhere, and certificates. Any more questions?
No, I just wanted to say that, there's a paradigm called zero trust security, which means like all communications, you validate every time, you check for certificates all the time, and you have very short-lived security tokens. So I think that's the golden standard these days.
And that's also based on what you have and what you know.
So you have a certificate that you start out with to acquire a token, which you then use every time, and you can validate that every time you send something. It's easier to work with, and you can even set up for how long time a token is valid. So even if it's stolen, it's only valid for 5 minutes or 10 minutes. So the likelihood that it's misused is very low.
And also it's important that your certificates are short-lived, so it's not 2 years, because, you know, if you steal that as a secret key, you have 2 years to hack, so you go down to have maybe 24-hour valid certificates.
My question is about how, because I've never been to the black market for cookies, obviously. What is it, just cookies, or is it other information tied with them, like the user agent and others? Can they see those?
Usually it's enough to get the cookie, because most developers does not check the user agent or the country. It's more like the advanced level, but the usual website does not care about, you know, those information. So the cookie is enough in most cases.
I understand, but the hacker can also imitate the user agent and also use the VPN for that. So the first two methods probably wouldn't work that much.
So yes, they can, you know, imitate the user, but it's usually maybe harder to get the user agent details. But it all depends on how you are attacked. But, you know, somehow the cookies are lost in transition perhaps, and then, you know, it's all about trying to get clues about the user. You know, is it really the same user now as same as before? And user agents and you know, IPs, a few clues. We will look at a few other things later on. But it's all about trying to get some, you know, hints about, you know, is it really the same user, or are we unsure about that?
Yeah. Thanks.
Okay, good. So, and also on fingerprint.com, you can also see some more kind of, you know, how it ties and you know, the kind of, you know, fingerprint ID ties windows, and to create my kind of unique identifier for my visit to this website. But also, fingerprinting is also a bit controversial, because it's all about privacy. You know, it's really, really hard today to be private. You know, just go into incognito mode on the browser is not really enough if you want to be hidden on and anonymous on the web. They can track you anyway. And also, they have been, you know, trying to, you know, so companies like Google have actually tried to kind of, we won't, you know, use fingerprinting on you until like last week. You know, now Trump is in power. Now it's all in, you know, fingerprinting, everything, you know, try to track you as much as possible. So this came out like a few days ago, 19th. So now Google will kind of lift a ban on fingerprinting. So expect to see more tracking on the web.
Yes, it's cross-device, but I thought fingerprint was linking this user to this device. So what is
to the browser?
To the browser.
Yes.
But if I have my phone or my computer, that might be different, right? So
yes,
how does this work?
But usually maybe you're logged in as well on Google and Facebook. So it's all about tying all the loose ends. So
but then that's the cookie session from Facebook.
So they set cookies anyway, but also fingerprinting and other kind of clues about your browser navigation can tie you to the phone, and so it's really, really hard to be anonymous on the web today. So that is a problem. So fingerprinting, you know, has this power if you want to protect your website, your users and the system, but also it can be used against you to do tracking. And if you want to kind of be more secure at home or at work, you can try to install a Pi-hole. So a Pi-hole is a Raspberry Pi software that you can deploy in your local network, and actually it becomes a DNS server at home, your local DNS server, and it downloads like a blacklist of blocked domains. So you can actually block quite a lot of this kind of tracking that is going on in your home network. So all devices connected to your Wi-Fi will actually be kind of less tracked. So I think that is really a good software, and I've used it for several years, and it's really, really useful if you want to be slightly more protected on the web. And it also blocks against quite a lot of different bad domains, like for scams and ransomware and viruses and other things. So it's really a good thing to have in your home, and you can actually block list, like Google Ads and Facebook and other things. You can actually see a log of all the domains that has been queried on your home network. You can, see lots of statistics and audit log and a lot of other things. So it's pretty good software for that. Another thing is session confusion, and maybe not so frequent, but still an important thing to actually discuss and bring up, because when you log into a website, so if Bob logs in, you're logged in as Bob, and you log in as Alice, you're Alice, and you log in as Max, you're of course Max. That is of course what we expect of the web, but not always, because sometimes they make mistakes. I mean, not an attack, it's more like developer or infrastructure mistakes, that you log in as Bob, but you become Alice, or log in as Alice and become Bob, or you log in as Max, you get a Max cookie, but you're still Bob, in the user interface. Has it happened to you? There's a few here, yes, a few hands.
It happened recently for a website called Nordnet.
Yes, I'm coming to that.
Okay.
So actually, it happens. So like GitHub, gave out the wrong cookies to the wrong persons, clearly a bad thing. And last week, yes, as you said, Nordnet, customers could access, other customers' account data, make trades and payments, what a benefits, And, as someone said on Twitter, they could log in and access some other person's accounts. Clearly are not a good thing. I really think that, I think this is one of the most scary attacks and problems we can have in the I mean, not an attack, it's more a bug that we as developers, cause. So I really think we should try to, in our security checklist, have you ever actually, thought about this problem? Have you maybe tried to add some extra kind of security checks so that if this happens, we can detect it? Because it's really, sure, it's rare, but if it happens, it can be pretty devastating. And I mean, it's not an attack, it's more like a mistake we do, but I really think that we should have it in our security threat model, what happens and where can it go wrong in this place. And of course, many times it's about race conditions, caching, that can cause it, but still, I think it's a really, really scary problem that not many people talk about. I hope you agree about that. So, okay, so we see that cookies is a problem, but how can we step up? Well, we could, we have all seen all of those kind of, SMS verification codes. We have all used them, but are they secure? Are they good? No, good. It's not good. And I want to play a short video about phishing and phishing attacks. Let's find the video. So this one, a short video. Let's see if we can get some sound as well. That's it, no, not that one. I don't know if you have some sound here, but
I think there's loudspeakers in the project.
okay. Let's see. Black magic.
And an internet connection.
We help people with.
Okay, so we start again.
Invited Chris to hack me with his team, but they're going to hack me using social engineering, which is essentially hacking without any code. They just use a phone and an internet connection.
We help people with human security issues by testing vulnerabilities for like a network test, but it's for the people network. We test those vulnerabilities, see where the holes are, and then help people learn so they can patch them.
Can we try some of this? Can we try some?
Yeah.
See if it works.
We probably could have our star Visher here make some phone calls as.
Let's do it.
Sure. Do you want to do a sample phishing call?
What's phishing?
Phishing is voice solicitation, and basically what you do is you use the phone to extract information or data points that can be used in a later attack.
Let's do it. Who are you gonna call?
Maybe I'll call your cell phone provider
Okay.
and see if I can get them to give me your email address.
I bet they're good. I bet they have my back. But yeah, go for it.
I'm gonna spoof from your number, so it's gonna look like it's calling from you.
Okay.
Hi, I'm so sorry. Can you hear me okay? My baby, I'm sorry. my husband's like, we're about to apply for a loan and we just had a baby and he's like, get this done by today. So I'm so sorry. I can't call you back. I'm trying to log into our account for uses information, and I can't remember what email address we used to log the account. The baby's crying, and can you help me? Awesome.
In just 30 seconds,
email.com?
Jessica gets my personal email address.
Now, if I needed to add our older daughter on our account so she could call in and make changes, how would I need to go about doing that? You would have to send me a secure PIN through a text message? Yeah, well, the thing is, I don't think I'll be able to receive a text message if I'm on the phone. Shh. Oh, I'm not on there either? So I thought when we got married, he added me to the account. Okay, my
Jessica uses my girlfriend's name and a fake social security number
5127.
to set up her own personal access to my account.
Wait, I'm sorry, so there's no password on my account right now? Can I set that up?
She even gets the support person to change my password.
Thank you so much for your help today.
So she just basically blocked me out of my own account.
I'll get her fed after this. All right, thank you.
Holy shit. So they just gave you access to my entire cell phone account.
You're gonna have to go on and change your password now because it's Jess, my name.
And all it took was a crying baby and a phone call.
Yes.
I really thought that my cell phone company would protect me. I mean, like.
So it's a really nice video showing and highlighting the problem here that just using a password is not good enough. SMS, is not maybe good enough. But, I think we all agree now, like 2025, that username password is not good enough. I think we can all agree on that. So what can go wrong here? Well, so let's try, and we are developers, we are professionals. If someone sends a link to badsite.com, we would not fall for that trap. We all know that, we are professionals here. We all agree on that. And if some hacker would try to create that domain, make some proxy and trying to fake, and try to intercept the communication, that would of course fail. We know better than that. But what if the hacker buys a domain that looks similar to GitHub, like glthub.com? That would be pretty bad. And actually, if you go online, you can actually buy it or try to buy it online for $2,000. Pretty good domain name. I mean, if you want to send it, not many people will actually detect that is not the correct GitHub domain. Correct, right? So that is clearly not a good thing. And that we could easily fall for this kind of trap. So actually, there's actually a website where you can go and buy domains. There's a marketplace for those. There's many marketplaces for domain names. So clearly, this is a good example of how easy it is to get fall for the trap. So the question to you, okay, we have all used the mobile phone authenticator applications. Will they protect us? What do you think? Is there no here? Just raise your hand if you think it's good enough. There's a few who raise their hand, but it's not. It's not enough. So let's talk about mobile authenticators. So, they will not secure it, because if a hacker have a proxy in between, you authenticate, you fill out the form here, he passes this on to GitHub, and you enter the code, and you do the dance back and forth. But still, this man in the middle here will actually capture all the traffic, including the code. So he will eventually get the session cookie, and then he can log in as you. And do you really think that is possible with mobile authenticators, that he can capture and get the cookie? Yes, you think? And so let's try that. Let's do a real demonstration of me trying to hack a GitHub account. So in my setup, okay, we have GitHub, that's our kind of target. I will create a proxy server here on my domain tndata.se, that's the domain I own, because we also want HTTPS. I mean, today, modern authentication often breaks if we don't use HTTPS, and also makes it more legit to use HTTPS. So we need that. So what I will do is create a phishing link, GitHub, tndata.se, and of course, yes, it's just for demonstration purposes, but if I have the GLT hub or some other more kind of, fancy domain, I can actually try to send it all to Jacob here and try to get into Lund&Bendsen's GitHub account. So how do we do this proxy? In our case, in my case, I use a software called Evil Jinx. So Evil Jinx is a proxy just for doing that. And I can actually log into it here. So I have this machine up and running. And so this one, I have prepared with a GitHub example. I do have a GitHub specific link I can use. So, okay, given that link, I will send it to my victim. So I send to Jacob here, I want to hack you, I send him some really, really attractive, like a GitHub Copilot AI, everybody, Jacob wants to go into the AI track.
Love AI.
And you use that link in here. And, okay, so I go to this, I copy this link, copy. I go to, let's say, Chrome. I can go into, like in this mode here, go into let's say, go into some yes, whatever repository. I log in, I send it, so I paste in this link. So I end up on the GitHub login page, but it's on through my proxy. It's HTTPS, but I see the real GitHub login page. And of course, I will sign in with my really, really secret user details. Here, evil, like that, and I copy my really secret password. I click on sign in. I'm still on the kind of, my phishing domain here. And now I need to enter my two-factor authentication code. And that I do have, I'm evil. So I will go to my authenticator app to get the code. And I enter the code, verifying I'm in. All is good. I log in, Jacob logging in here now as a GitHub, and start pull requesting, and creating issues and fixing bugs. All is great. But in the background, me as a hacker, I go back to my thing here, and it says that, I actually captured a session here. All of the session tokens intercepted, password, username. Oh, the juicy bits. So I can actually go in here and to look at all the sessions that's been captured. At the moment, I only have one. So I can actually now see details about it and also see all the cookies. So given all this cookie information, I can copy all this string. I can go to my other browser. So I use the kind of Edge, I'm a hacker, I use Edge, of course. and everybody uses Edge, of course. So if I go to github.com, I can go in here, I can maybe go to some GitHub, some random repository. This is my open source project. I'm not logged in. I'm on the hacker's browser here now. I click on the sign in. No, I don't need to do that. I need to. So basically, what I want to do is to import all of those cookies into Edge, but there's quite a lot of different cookies, and I want to copy all of them, and copying them one by one is pretty kind of tedious. So I have a plugin. I'm a hacker, so I have a cookie plugin, a cookie editor up here in the corner here, and here I can actually import that entire JSON blob. Click on import, cookie was import, and if I now will load the page, I'm logged in on Edge as evil test. So even though I use the authenticator app to secure my account, thanks. So even though I use the authenticator app, I was still hacked.
Well, at least you used two-factor authentication.
Yes. So that's a check, on my security checklist. So clearly that is not, good enough to just use that. We need to do better. And the solution is, of course, to use, YubiKeys, that kind of keys, and similar. I have them here, and you have also, those kind of keys. Or you can use the computer or mobile phone, because nowadays those keys are actually built into your phone and computers nowadays. So you can actually tie your computer or your phone to GitHub to further strengthen your authentication session. And that is really important. And also I think for us, the developer, now kind of wrapping up here, that we should ask the user to authenticate each time we're doing something really sensitive. You're like changing accounts, account details, making payments, to do it more often when we do really security sensitive operations, because just having a long session cookie for weeks and you can do everything like an admin, maybe it's a bit too dangerous. Maybe you should have a step up, a privilege step up, that you, when you want to do something more dangerous, then you ask for I want to be admin for 30 minutes, and then you go back to normal user. That's one approach. And finally, those authenticator apps, it's better than nothing, but still, can we trust them? Because actually, some of them leaks your secrets to Google Analytics. And I actually did verify this one for this authenticator app, that you think you're secure because there's still some secrets added into those apps, and that secret is actually leaked to Google Analytics. Game over anyway. So, questions?
Yeah. Will you start again?
Yeah, sure. I'm a little confused. How does a YubiKey help you protect from this vector? Because I presume there's still a challenge response, and the challenge would just go through the proxy, and the response would go right back.
So, good question. So, with YubiKeys, what happens is that when you register a YubiKey with your with a service, what happens is that it ties, first of all, it's JavaScript and a browser that talks to the key, not the backend directly. And the JavaScript has an API built in for talking to those kind of devices, or your computer or on your phone. It's all kind of built into JavaScript. And it's all tied to the domain name in the address bar. Oh. So if you're on a phishing GLT hub, the keys won't match, because the key added here is tied to the exact domain name up here. So if you go to a slightly different domain, your key won't work.
Okay, so unless you get the user to install a fake extension of the client-side software, then because
it's built into the browser and operating system. So
okay,
it's kind of.
They said JavaScript, so I assumed there was a browser plugin.
So basically, it's only one line of JavaScript that talks to an existing built-in API in the browser that then can talk to these devices, or your phone, or your computer. It's all kind of it's an ecosystem for that. So you just call one method, register a key, and it's all kind of handled magically in backend. Yep.
Hvem var det? You see passkeys in this. I know they're not completely better, but it takes care of the bad passwords, right?
So actually passkeys or those keys is the same thing. Passkeys is only a rename of a standard called
passphrase.
WebAuthn. Let's see, there's my glasses. So passkeys or WebAuthn is basically the same thing. Basically, when you register, you can maybe say like a tour here, register, and what happens is that this is a Windows security. This is not a browser thing, so this is really tied to the operating system, and it asks me to insert the key in the computer, and I can register, this domain, and I press, OK button, and now I need to enter my PIN. So I do have a PIN on this key, and then I have to touch it to really prove that I have it in my presence. And then I need to kind of authenticate, and I press the key and touch it, and then I can get into the site. So passkeys, WebAuthn is basically the same thing. Passkeys is more like to make it more human friendly. WebAuthn was a bit too scary for end users.
I think just a comment for what Jan said, isn't it, as I understand it, when you register, to the point is that you register your key with your provider first, and therefore the provider knows, sort of gets something signed with the private key on your physical key or your pass key, which means that you cannot fake it later in a
No, it's really, really secure, because when you registered, the backend will send I think it's like a challenge or something down to a browser and down to the device. It's signed by a private key and sent back. So, but still, but the key is that this key is only used for authenticating. But then you still get a session cookie, because this is not your session cookie. This is only for proving who you are. You still get the cookie, so the cookie problems are still, the same. This does not help.
No, I understand. No.
For that.
But the other question was about passkeys. Is it correctly understood that passkeys are basically just software WebAuthn tokens? So the secure thing about this is that you cannot pick the private key out of it. Yeah. With your computer, you have to trust that you cannot pick it out.
So this is what came first. And then passkey became more, but you can actually use a phone instead of a key. And it also allows you to export your key and sync your key between different devices. And that is, of course, a gray area. Do you really want to sync your keys across devices, all your iCloud account, or not? And it also works for Android phones as well. You can sync those keys. But, of course, this is even more secure, because that private key is stuck in just this key. And that also means that you really need to have a backup key as well. And I really like to see those keys as your house key. If you lose your house key, you need to have a backup, a few backup keys, with the kids or, your parents or whatever. You need a backup keys in case you lose your main key.
Yes, so you start out with a lot of talking about, how and when to invalidate the sessions when we kind of notice something going wrong, because I guess it's not quite feasible to demand all of our users to go passkey way. As I was kind of surprised to see that actually GitHub did not invalidate your session despite you going to Edge. Do you think like it's an issue for them to not do this? And
it's
do you think it's
demonstration purposes?
Yeah.
Yes.
But do you think that popular web frameworks or like yourself as developers should pay attention to these kind of things as a user agent or other kind of
I really think that we need to raise the awareness, like what I'm doing here today, so that we bring up a discussion internally. Is this something, an attack we should kind of try to cover? How sensitive is it? And what's the impact on our customers and users of our services? And it's all about risk management, Is this a bank or is it like a simple blog, It's all about the risk and the trade-offs. But I really think it's about, raising awareness about the cookies, the problems that can occur, and, the dangers of authenticator apps, and why you should use WebAuthn or passkeys or similar devices.
So is it legally okay to demonstrate it? Didn't you commit a crime there, identity
Well,
theft?
it's my own account, so it's my own data, so I'm not hacking anyone.
It's just it's identity theft is a crime, as I
but
understand it.
I am hacking myself, so it's fine.
Okay. Yeah.
We hope.
What about aren't there authenticators that actually talk to the backend service directly?
Yes, they are.
They should be as secure as your key, right?
Yes, there are kind of different upgrades to those authenticators, but you need to sign in here, or you need to enter some code that you see on the screen. So they are trying to kind of raise the kind of bar, but those are more site and service dependent. The authenticator app work with many sites. But if you're using Microsoft, they have like kind of increased the kind of security. But if you want to use like a generic authenticator app, they might not always understand the kind of Microsoft specific things. So it's difficult. It's complicated. Anyway, if you have more questions, feel free to catch me afterwards. And if you want to know more about security, I do have a training class with Lund&Bendsen. So thank you.